5-week website. Whether you're on the Jupyter Hub or not, the first 2 notebooks that I'm going to cover in the next 15 minutes are rendered on the website. You kind of navigate to the 2020 Jupyter Hub, and then well, that's the blue button, and then on the left column under tutorials, we can get to the one that is called SnowEx Mission and Dataset Descriptions, and then the first one there. So that's what I'll be showing here. Maybe this is a little informal, but I'm going to sit so that I can go through the notebook with you guys. Sweet. Well, yeah, thank you, HP, for the intro. And like I said, thank you everyone for being here. This is exciting. We have up here SnowEx, and my goal in these first 5 minutes is to give you a good visual overview and understanding of the different campaign types we've had, and to get a sense for the extent of data coverage, which HP kind of gave us a really great intro on. So I would say after now 3 years of SnowEx campaigns and 2 different campaign types, it's getting harder and harder to sort of like distill down the information of like what we have as it keeps growing. So I started by making this table that kind of shows you by year and campaign type what we have going on. When I refer to the campaign types, it's like what HP was talking about. We have the IOP, the intensive observation period, and the time series. And then we have the different campaign years. So again, we started in 2017 where it was just focused in Colorado. We used multiple instruments and we looked across a forest gradient. 2020 was sort of our largest year where we had both the IOP and the time series happening. And over 2020, we focused on the Western US, like HP said. We had the L-band INSAR instrument. We had different active and passive microwaves instruments to look at SWE, and we had the thermal IR to look at snow surface temps. While we also had the 3-week campaign at Grand Mesa for 2020. So there's lots of good overlap there with airborne instruments and ground observations. Due to the pandemic, we had some leftover flight hours, and we continued the time series in 2021, where we had a smaller set of sites, but then we also introduced more prairie sites and addressed some of the albedo questions. In 2023, we have plans to do another IOP style campaign where we'll go up to Alaska and look at the tundra and the boreal forests and have some more of the science gaps addressed. So just visually, we have like, where has SnowEx been? This kind of map helps you look at on the left side of where we've been in the Western US thus far. Obviously, this map will grow into Alaska. And then on the right-hand side, it just kind of zooms in a little bit more so that you can differentiate which years, which style of campaign, and then start to put like a regional location to each place. So you can see like 2020 was by far the biggest year with those 13 time series sites, and then down to 7 time series sites in 2021. Okay, so what's like this whole focus on the IOP versus the TS? For your application, maybe it's not relevant at all. I just want to make sure that folks are aware when they're grabbing data that basically the differences there are your like spatial coverage and your temporal coverage, right? So we have like these really specific, labor intensive, everyone out at one time style of campaign, and we're really focused on one area and like one snapshot in time, and we really cover an area, but we don't get as much of a temporal picture. Whereas the time series, we deploy more people that are local to the area and have existing infrastructure, and we try to represent like the evolution of what happened to the snow for the full season. So depending on if that matters to your research application or not, what I want you to know from that is like the observations that we're getting are as similar as we can possibly make them to both. So the core observations, your depths, your densities, your stratigraphies, your like all the things that we collect data on in the snow, the data set products, so like what we publish at NSIDC, our naming conventions, etc., those things, and then the processing tools that we're developing here. We're trying to make those so that it doesn't matter which style of campaign you're working with, those types of things you can account or like count on being similar. If they start to change, it's because we've found a way to improve it. So yeah. One other thing I wanted to draw your attention to is, again, something that really drives our missions and our mission planning is the fact that we want to study snow in a lot of different snow classes. So we want to cover that. This is a really great data set. I only have North America plotted here, but not plotted, this is just a figure. Sorry, I took it. But it's a global data set and it's available at NSIDC. The link is on there. And there's a accompanying paper with it by Sturm and Liston. That's a really nice description and they've updated it since 1995. Right here, what you see are the different snow classes over a 300-meter grid on North America. So like I said, what drives our campaigns is to know like what style of snow we're studying, vegetation, the terrain, etc., and take measurements in those different locations. So at the same sort of scale here, I've plotted where we've been with sort of the most recent campaigns, the 2020 and 2021 time series. All of our unique sites are plotted here. I realize at this scale, there's some overlap going on, but that's why you can use the legend here to sort of see how many sites we have counted at each of those different classes. So when we go up to Alaska, we'll be adding a lot more like tundra sites. We have really good coverage in the like warmer montane forests. We added some prairie sites. But like I said, this image kind of overlaps, and even though green is dominating, it kind of plots those ones on top too. So yeah, let's see. Great, so we're just gonna recap and just let everyone know that like all of our SnowEx campaigns are, we focus on the questions that are in like the science plan that's linked here. And some of these objectives are met by doing like an intensive all hands on deck style campaign or looking over like the evolution of the whole season. And then all of the coincident field and airborne observations are designed directly to answer the questions that we have for remote sensing gaps. And a lot of our decision making is driven based on getting a range of different snow classes, terrain, and vegetation types. So hopefully now you're a little bit more oriented with how big this is and where things are. So then you can click on this bottom tab down here, jump to the next notebook. Okay. Someone can shout at me if I totally go past time, but yeah, now we'll take 10 minutes before our break. You'll have a break after this. 10 minutes to go over, like we're gonna zoom in a little bit more and we're gonna look at the ground-based measurements. I wish I could tell you about all of them that we took. HP alluded to a lot more that we have, but I will keep it strictly to like what's consistent at all the different sites, and then focus mostly on the snow pits because that's what I spend a lot of time thinking about. So the goal right now, yeah, is to get you, I just kind of said those all will be good. Yeah. So visually, you can kind of see here, we have like 3 different kinds of data that we take a lot of. The snow pits, which give us a lot of different parameters. They're all listed down in the bottom of that image. I'm gonna go into more detail on those. We also have depths, which is a pretty basic data set of snow depth and a coordinate pair, but we just have a lot of different instruments that we use. So the instrument might become important if you're doing an analysis there. And then we have interval boards, which we deployed networks of those to specifically help with the UAV SAR airborne flights to look at the change of snow at a specific interval. So we measure the amount of new snow on top of that board you see placed there, and then we can measure the SWE and the snow density. Again, that's not obviously going to collect like a full SWE because we, you know, wind and melt and over time, but it's going to be like what the UAV SAR is seeing. So again, we're using these as our calibration data sets. For For reference, I have down here a little bit more information about what each of these types of core central to our campaign type data are. And then once we talk about the database, the parts in gray will make a little bit more sense of like what types of data they are. So a little more detail on snow pits. That's kind of like one of our main things that we do a lot of and have been very central to our time series and IOP campaigns. So the colored ovals in the images are all linked to the colored descriptions on the left side. So in the first panel on the left, we have 3 different types of measurements happening. Again, just you're in the snow, you dig your pit, you dig down to the bottom, and we're measuring a total snow height. The blue parts show where we took density cuts at 10 centimeter intervals. And then the yellow part there shows where we take liquid water content sensor readings, where we collect the dielectric constant at 10 centimeter intervals. The green in the middle panel is showing like how you would take temperature down. We take it temperature at the surface, ideally shielded and protected from the solar radiation, and then 10 centimeters down to the ground on even 10s. We mostly do that just so that you always end up down at 0. And you can kind of check your thermometer. Yeah, the orange in there kind of is to represent that we take qualitative information about the pit. We take environment conditions, weather conditions, canopy, vegetation, ground, stuff like that. And then the right-hand side shows taking stratigraphy in a snow pit. So looking at all the different layers, noting them, looking at hardness, and looking at manual wetness. We, from there, can calculate the liquid water content with the A2 photonic WISE sensor. And that's recorded in our data sets, and the snow water equivalent SWE from the depths and the densities, the average density for a pit. Just so that you can see it at its most rawest format, these are snow pit sheets that everyone has been filling out. You can see all the parameters that people are measuring in the field. Again, sometimes it's one person, sometimes it's 2 people, kind of like a team. I've added like a reference so that you can kind of, if you want to look at it at that level, or you want to work with the grain types, the hand hardnesses, the manual wetnesses, you can refer to the table here to kind of tease those out. This is the back of the pit sheet, where again is more of the qualitative information on the environment and ground conditions and weather. And then where we would have like the interval boards and some other data. So yeah, why is it that we care about taking these types of measurements? Again, we're looking to correlate these with the airborne and satellite sensors. So this is our main validation data set. I would also argue that some of us just really enjoy being outside and being in this. So you can all argue over the percentages that I put up there over our coffee break. They're not published anywhere. So yeah, like when you're in a snow pit, the things that we can see, some of the sensors also see, like things like dust layers and ice layers, surface hoar, whether it's on the top or a couple layers down, flow fingers or vertical movement of water and through a snowpack, different melt freeze crusts, grain size, all of these things make a difference in the instruments that we're using to measure snow at a larger spatial scale. So that kind of concludes it's a very high level look at our core data sets. Now I just want to make sure you have enough information to get going and you're not super confused by the sampling strategy or the naming conventions for these data. So I started with the 2020 Grand Mesa IOP. The sampling design there was to use a 9-member matrix to decide where we were going to take and like randomly sample snow pits. So we used the 2017 snow depth LiDAR to tease out 3 different classes of snow depth, and we used aerial imagery from Worldview Imager to classify tree density. So that created a 9-member matrix along with the fact that we had 3 flight lines, a cross line, a north and a south line. So all of that information is encoded in the site names. If you're working with the snow pits from Grand Mesa, you can see the cross line, north and south, and then the numbers correspond to whether it's tree, kind of open canopy, treeless, sparse or dense, and how deep the snow was from the 2017 LiDAR. So you can use those numbers if that is important, if you want to find shallow pits, if you want to look for, a certain type of grain type that you find there, if you want to work with deep pits if you want to find forest, deep pits, good luck. That's not generally, doesn't happen as much. Yeah, hopefully that's helpful. And when you're looking, so that these site names aren't just like a total blur to you, there is some information embedded in there. I don't really have you can't really see it super zoomed in, but it starts with the number of the matrix, the cross line, and then after that, it's just left to right. It works its way up. And then I want to give you a little bit of information to get going if you work with the time series data and how we coded those up. This table here kind of helps. We basically have like a location, which is like the regional location. Those were the 12 regional locations that took snow pit data, and then 7 in 2021. Sites, those are a unique location within that larger location. So maybe one site had 4 different snow pit sites. The site column there and the pit ID, those are the same. It's just that one is, site is more verbose and kind of tells you what we have going on, what the name is that people would commonly refer to that site as, and then the pit ID is going to be unique as well but it's a little bit nicer for scripting because then you like everything's 6 letters. So you can tease that apart and get some information out of that. The first 2 letters are the state. The second 2 letters are the location from the location column. And then the last 2 letters are the site. So you can use different queries, if you want everything from Colorado, if you want everything from Colorado Cameron Pass, you can kind of use those codes to help you there. You can then see that there's 2 other columns there, the pit count, that's how many pits if you sum everything from the 2020 and the 2021 campaign, and the snow class that I showed you from the first one is each of those snow classification types has a number corresponding to it. And if you get the paper, you can see, or if you look at my plot, it's in those orders. This table is still a little bit preliminary. There is like a few other pits, random, or there's a couple other things. If you know the data set really well, you might see some that are missing, but this is like 99% the bulk of everything. So I want to make sure that you have access to this table if you would like to use it. So down here, yeah, so I explained the little bit of exception here. But to get access to this, you can you can find my GitHub, and it's a gist in my GitHub. You can also use this link. There are some steps listed here on how you want to copy and use that. And then, great. And then you can pull that table in using this line of code right here, and it will come in as a GeoPandas data frame. Yeah, if you have any trouble with the link, I can help you with that. You can use this exact line of code and copy and paste it, and it will work. I have a couple other gists up there if you want to look at or ask me about what exactly you're grabbing. Cool. So the last little section here is just a really high level, like where can I find this data? Because we have a lot of other tutorials based on that. But I just want to give you some reference material here. Again, we archive, publish, and store all of our data at, well, most 99% of our data at the National Snow and Ice Data Center, NSIDC, which is in Boulder, Colorado. From the core data sets I've been talking about here, There's a table. Again, it shows you the parameters that are available, which instruments, and then which ones are published, which ones are in review. Some of them that are in review, like the time series snow pits, that is available in the database, and we're starting to work with that. So just if it's not exactly published, we can still kind of get our hands on it. But yeah. So if you go to NSIDC, if you were to click on that link there, you would get to our nice landing page. And then there's tables there that show you by year what's published, what's all there. Again, there's a lot more data sets than what I've showed you here. A lot that are like site specific, etc. But if you were to download all the snow pit data, you would get basically a package that looks like this. All the parameter files are in CSV format, along with one master summary file of an environment and a SWI file. And then you get the pit images that were part of each pit package, the raw books. So this kind of shows what's all condensed into like one snow pit. And then my number 2 point here always makes me sad because there's not an image with it, but that's because that's all the data that's stored in the database, which will be after break. We'll go over that tutorial, but that's where we're going to access a lot of data for Hack Week, which is really exciting. So to recap, you know what a lot of these measurements are and how they interact between the different campaigns. You know the basic sampling strategy and between the campaign types, and you now have a few tools on how to access things or to grab some of this for Hack Week and plotting, etc. So with this little bit of time that we have left, if everyone can click on the Google slide there, should have some editing access. And I think I will separate out, well, here, I'll click on it so that everyone can see it. Okay, this can be kind of individual. Well, no, we're gonna do the tables thing. So I've made a mind map now that your mind is thinking about all this data that I've showed you. Or specifically, if you came with ideas in mind, we're not doing like project pitches or anything right now, but I'm interested in kind of getting data from you guys on what are all the different applications you see. So now that you know there's all these different measurements, what are some things that you've thought about or you've thought about with your advisor or whatnot that you want to plot, see, think about, like 2 things that you want to compare, 10 things that you want to compare. So I think everyone has editing access, and I'll just say that I'll just kind of like assign people tables and like add to it. Like this table 1, you guys can all add to table 2. That's enough for 3. Maybe we'll split this one into table 4, table 5. And you guys can all coordinate on tables 6. I don't know. Maybe like 7, like everyone add to 7, then 8, then everyone in the blue chairs add number 9. Or add whatever table you want, but you can talk amongst people, you can add to them. Yeah. Yeah.
Good job. So we were thinking about wrapping this into a break activity, like, hey, you got 30 minutes to do this and do a break. Is that okay? Yeah, like people think separate. So you want
Hello, everyone. We're going to make this a work on this, and we get a 30-minute break kind of time. So do this. Feel free to move about, take a break. We're going to resume with tutorials at 10:45. Do I need to say anything else?
to follow and log into the Jupyter Hub. So my first question is just raise your hand if you have successfully logged in, or do the other way around. Who has not successfully logged into the Jupyter Hub? That's great. No, there's one. Okay, I'm gonna make sure to follow up with you there. So, and also I want to highlight that if you do run into a technical challenge during this week, there is a Hack Week Help Slack channel. I think most of you might be members of that channel already. So if you run into something, you know, you have like a technical snafu, feel free to post this there. And I think we all can help each other out here, and everybody has done something at a certain point. So it's really kind of an open help forum to get help on anything technically, Git, Python, Jupyter Hub, or anything like that. And you should be good to go. Figure it out. Very good. Look, there's a good example. Without the hat jump, what do you know? That was good. All right. So I also have to sit down, unfortunately, because I need to present a little here. So raise your hand if you can hear or see, follow me along here. So the hub is basically our shared compute environment we use in order to have for you the technical Python setup that you can just start crunching away without having to install all these Python packages. If you're interested how we did that, that's also a technical question or a help question. So we do have documentation around that, which I don't gonna go into the details right now. A few things I want to highlight right now, if you know here on the GitHub tutorial, which you can reach again, tutorials on the Jupyter book. Then you open up those tutorials, you fly out this little menu, GitHub Jupyter Lab, and then you see this link right here. When you click on it, this is the tutorial. A few things to note for the website. So this is an interactive development and what we did as a group as well, and you can contribute there as well. For instance, here up here on the top right side, you can straight go to the repository and see how we did the content contribution. You can also suggest an edit. So if you see typos or anything like that you think that can be improved upon, you can either suggest an edit straight away if you are comfortable with issuing a pull request, or you can just open an issue so we at least log it and we know what's going on and we can see them coming in as they arise. The other thing I like about this is as well, you can download here the markdown file, for instance. So this has been written as markdown. It's kind of nice to just straightly download it without having to, you know, clone an entire repository. And if you don't know what clone means, I will give you a quick refresher in a second here. And also, for instance, I want to highlight earlier, when you go to any kind of tutorial that has an interactive Python notebook, and you ever want to go out there and share with a colleague or say, quick, you have to look at that, you can go up here as well and you see a .ipynb link. So this will allow you to straightly pull the Python notebook without having to, you know, send someone the whole repository where you just want to show him the modeling component. I think it's kind of nice, so that's why we all like it to use this. Okay, so go back to here to our little GitHub tutorial. So first time Git setup. Again, let's do it the other way around. Anybody who has not been able to successfully set up his Git environment there? There's one. Okay, so let's do it again in the same fashion as earlier. Do a quick note in the Hack Week help channel, and then we can follow along with you during our breaks, for instance. But in the sake of interest of time, so I can also show you a little bit more how to follow along with the next tutorial. There's a few basic commands if you followed with Eli's intro tutorial for the Git itself. So Git is our way to version control the code that we did. And it basically is a software that helps you maintain and track your code and your code changes. There's a couple commands that we're gonna hear and do throughout the week, which is basically a Git clone. I'm gonna start in the middle, of course, as it makes sense. To get down a repository, and repository meaning a collection of code copied down to your computer. Then if you want to see what has been done to the repository in terms of history, you can do a git log with second command, which is kind of a diary entry. You can almost say everything that has been changed and has been tracked is going to be a git log. And then there's the other 3 commands, or 4 commands, I guess you should say, is when you do want to make changes, you go ahead, you edit some files, you have to do a git add, which will add those changes, as I know this is going to be tracked now as a history entry. And then actually when you do the initial commit command, this is when the history gets written. So basically before then, you kind of in the editor mode, do things, you add it, you think, okay, this is a good change, but now we do a git commit. So this is what we say, this is a good commit, usually referred to as a git commit. And then the other thing is if you want to share your changes, you have to do a git push, which means now what I had locally on my repository changed, and you do in actively development with a GitHub, which is a shared environment for version control, then you actually publish, so push it out to the world and everybody can access it. And then if someone else wants to get that, he will do a git pull. So use kind of this is kind of a jargon kind of review what I want to give you right now. So it's like a git add, git commit, I had to make some changes, a git push to publish those changes, and then a pull to get it all down again. And then for the next thing is also when you do want to now follow along interactively within our Jupyter Hub. So the website, you can clone this down there, so make a copy of it. So there, for instance, if we go, let's go. Should have done this earlier. Let's go to the Jupyter book as a quick. And then we have all these links right here. So this is the hub right here, the organization right in front of you. Let's open that. So if you do a login and continue, so now if you all do this probably once, I tried to pre-warm the Jupyter Hub a little bit, so it's not overloaded for us logging in once. I guess it didn't quite work out. There it is, the little challenges we face all in all. There it is. So you have to imagine now everybody kind of logs into the hub and everybody gets its own little compute environment. So this is kind of your user space. You can do whatever you want in there, like no one else will be able to see, or you're not going to stomp on each other's feet, right? So this is an isolated environment for you to play around and explore all the great and data from SnowEx here. I already did this here, which is the website. So this is the copy of what you see online right now, I guess from 10 days ago, as it tells me. I should do an update. But for instance, here, I think Eli showed it as well in her tutorial, you can also, if you're inside a repository, you will notice here it says current repository, and you are on some sort of, if you are on a branch, you're most likely going to be on the main. So branches, as a quick kind of refresher, is like multiple copies of different paths you took with this repository. So you will notice here, left-hand side tab has this Git panel. If you're inside a repository, this is a good indicator for you to tell, okay, I'm inside one. But for instance, if I would go out there and go into my root folder, which is root meaning my home folder of my user, and now I go to my Git plugin, you will see it doesn't know about it. So now it is an indicator for you. This is the location you're currently on the hub is not version controlled by Git. And now if you would have to get your copy of your website, you would hit that clone button right here. And now you see this little prompt. This prompt wants you to get a URL, which I can get from our GitHub site. So here we're going to just navigate to the website. And up here, you see the code button, the green button right here. And then I usually check the HTTPS, which is just a different kind of URL. Copy this right here with this little copy button. It will also give you a little memory here, and you just paste it into this repository. So I'm not going to execute it now, because as you saw, I already had a copy of it, and will basically tell me, look, you already got it. But if you haven't done it, go ahead and just hit that clone button. And then after a little while, what you should see is the same thing what you see right here, which is called a website 2022 folder. The way the naming convention works right here is that if you go to a GitHub repository. It has a name right here, right? Website 2022. That's exactly going to be the name, right? This one right here. That's the name of the folder it's going to create once you clone it via that URL. So there you have it. So website 2022. And now for you to be able to navigate to the tutorials you want to follow along, it has a little different structure than the website because it's basically both worlds. You see the front end website, like the splash page, you're already applying and looking for the schedule, and then also the Jupyter book. And that's exactly what I'm going to do right now. It's like I go inside the book right here, book folder, and then you're going to see the tutorials right here. And this is where you're going to see and follow along all the tutorials here we gonna have throughout the week. Some have more than one, so they're gonna be organized in folders. And I think the tutorial leads will also can point to that if you know if they say left hand side of the link, or they even will be able to tell you which folder they did. And I think for instance here, core data sets, that's Megan right here, and you're gonna see 1, 2, 3 about her to follow on tutorial. And all you have to do right now here is open one. I guess it's the least interactive I just picked. Good choice. Yeah, and since my content is not quite up to date, I would have an interactive cell. But basically what you're going to have here now is the Jupyter book as you saw it on the website. And up here on the side, I don't have a kernel activated. So a kernel is basically the Python environment that we set up for you with all the libraries that you need to run the notebooks. So if you see up here on the top right, no kernel, just click on it. I can show you that again. Top right corner, you see there's also a little white idle button, but you can here then activate the kernel. We only have one, but this is the one you need, so don't worry about it. Or I guess you could switch kernel if there's multiple ones, but for us in our simplified environment here, is that you activate it and you see right here, now it says IPy kernel. And if I would have picked a better notebook, which I'm gonna do now, not better. Man, I really should have did it. Third, there you go. So here's the compute environment. What you see on the left hand side here, there is kind of a square brackets that's empty. That's an indicator this cell has not been executed. So all you have to do is what I tend to like as a development flow, just shift enter. This will execute that cell. And you see like a little 1 now. That means this kernel session had now 1 cell that's been executed. You can also hit the play button, which is up here. There's a little bar here at the top, and there's a play button, which you can also execute cells. And then there's also, I think, one in those menus up here, but I'm a keyboard addicted person that likes to just hit shift enter, control enter. So that's the way I navigate fastest around long notebooks, for instance. And then also another thing that people like to do, or maybe sometimes forget. So if you now say, you know, hell break loose, I just want to start from scratch again. I don't know what I did too much. You can also restart your kernel. So restarting your kernel up here means basically you start as if nothing would have ever been executed. And then just also make sure that now that you have a fresh state, you have done nothing yet, you have to restart, you also execute those cells again you had executed before. And you also see that by, again, it's the number 1. If I would execute this again, the running counter. So now you have like executed your cell over and over again. I want to pause here before I get for a second. And anybody who has questions or stuck somewhere, raise your hand and we can maybe figure it out.
Remind folks how to watch what you're doing through the Zoom link. It's quite hard to see on the screen. Just give people a reminder that watching along on Zoom is a good way to go.
Watching along the Zoom, would you like the...
I was just going to offer a reminder that clicking on that Zoom link so that you can see where Joe is with his cursor. And
oh yeah, sorry.
Because I know we're working on this projector issue for tomorrow, but for today, following on your computer through the Zoom link that we offered at the beginning of there in the general channel is a really good way to go. And then we had a couple folks in the help needing to be added to the GitHub organization?
Okay, that's easy done by sending me either a direct message or follow along the thread. Give me your username you have on Git, and I can add you or anybody else who has the privileges there. I will be able to add you to that, and this should also then be. This is basically the way we control if you have access or not with the Jupyter Hub. So I will then add you to the GitHub organization. And then you can be also log into the Jupyter Hub. So this could be one reason why you can't log in right now. If we don't have a username on the GitHub organization, you won't be able to log into the hub. It's just, it's easier to make a one login shop to have you through the GitHub as a organization. I saw some hands somewhere. Jack.
There's a bunch of different options for virtual machines when you're logging in. Is there any you would recommend? Should we not do the big one? Will that overload it? Because I remember last year we overloaded. So do you think you need the huge cores, or do you just go with the 4 core 60 gig RAM one?
All right, so the question was, when you log in first into the Jupyter Hub, you can get this little prompt about what instance to choose, what size. So my rule of thumb there is, the first option you see there is like a 2 core 8 gigabyte. It's kind of like I don't want to say standard laptop these days anymore, but it's kind of a laptop, right? So there, I think if you just follow along the tutorials, it's going to be plenty fine. And use that. And then actually what we do want you to try for your project work, if you do have a big analysis you want to do, you want to go through all the UAV SAR at once. This is, I think, the right time to say, look, now it's the time to step it up and use the bigger instance. So, the way this Jupyter Hub runs is on AWS or Amazon Web Services. We do have a bunch of credits that we have for this event. So don't be afraid to run the big instances if you need them. I mean, there is room, there is space. Just, do your own good decision there. It's like, okay, I just follow a tutorial, small will do, right? I want to run a big data set. Yeah, use the compute power we have. And we do also, if people are interested in using GPUs, there are instances available for GPUs, and this is actually the first time of an event we have this available. So you have a project idea that can use GPUs. We would be really psyched to do that, or for you guys to use it. So we know how it goes, how it works, and if we need to tweak something there. And I mean, every event you see here, we kind of change our compute environment, or not change, but evolve, I should say. So it's good to know what you guys need, what you guys want to use. And for instance, if you say, hey, we need a better, different instance configuration, that's something that's good feedback to know after this week, what you guys have been done or have been using mostly. Any other questions, technical terms or navigation kind of things? This is great. This has been the first event. There's only been a couple of questions about the GitHub stuff. And yeah, just since I just mentioned it, GitHub, if you have not used it before, it is a behemoth to learn, but I think we're all here in the same room to haven't gone through the journey of GitHub. There's many folks that can probably tell a lot of good stories. I love Micah stories where he lost his work and then learned about GitHub, how to use it afterwards. So we don't want you to go through that. And but yeah, so reach out if you need help there, or you want to also, if you want to do some advanced kind of more GitHub related project organization, we can do a little one-on-one session there for your project groups. If you want to, get it more involved there. There's no, do I have to learn GitHub for a successful hack week? I say the basics will do you. So you will have to navigate Git and GitHub a little bit, like two of the terms I showed you, kind of the Git clone and Git pull are probably the best of the terms you should get familiar with, just for us to provide you the content and you getting the content you need. And then I would, my tendency would be then I think it's a good way to learn as a group, for instance, and help each other out there to help that person navigating if that person hasn't done it much before. But I don't think it will require you a lot of kind of technical expertise and be a full-fledged developer after the session that you learn GitHub. And I also always say, GitHub is a nice tool to have in your toolbox, but for this event, I think the focus can definitely be on, let's get you familiar with the data sets, and I think there's enough people in the room here to help you navigating, getting through the Git and kind of challenges with terminology and all these weird concepts that you're gonna hear. I mean, I've done it, I use it now many years, and there are still things every day you look up on your favorite search engine or Stack Overflow. It's like, how do I do this? I just, I'm just in the boondoggle here. So don't be afraid to reach out. It is like I said, it's a challenge to learn in the beginning. And I felt personally that it's not just like something you pick up like Python. No, it's a different kind of thinking sometimes as well. So, but don't be afraid. It's useful. It's a challenge to learn, but I think it will pay off to put in your work once you kind of have the basics down. Eli.
Great. So the project is brand new to GitHub, then it's not necessarily goal efficient in GitHub by greatly. So many of them.
Just a quick check here. Did everybody, or was everybody successful to clone the website down right now? Because I think Megan, negative? What was the? Basically, this, so this is, I guess, one of the things I mentioned earlier, to go back to, or you have to get basics down. So if you try to reclone your image, in order to update the Git basics, you go inside the folder. And you do Did anybody else find trouble having clone first? I guess we can do a quick 5 minutes. Everybody can check out with each other, walk around the room, then. Yeah, so everybody, like Megan made a good point, try to open this notebook right here. Then the third, Megan, the third one, number 3. Yeah, exactly. So again, you can't see my cursor well, but if you're in the website repository, there is a book folder. Go inside the book folder, go to tutorials, and then it will be the database and the core data set folder. Yeah.
15 more minutes with me and then on to some project stuff, I believe, for lunch. Is everyone able to navigate inside the Jupyter Hub, clone website 2022, and navigate into the directory, I think is books, tutorials, core data, and we're on the third notebook. Cool. Okay, if not, there's the Slack, get help, and yeah, let's not be lost. Speak up if you're not where we all are. Okay, so this is the third notebook, and we are going to do a database preview. And as long as my fireworks don't work. Yeah. Oh, good. Interesting. Has this one been pulled? Maybe I should check. Joe, I'm logged in on you. Shit, I don't. Just make sure we're up to date over here. I don't know.
You want to use yours or should we?
You can use mine, it's fine. Or
Yeah, I would say just log out. And then also log out of GitHub. Do you have your password for Git?
yeah.
Yes, we can all just
Yeah,
pull, we can also do Stu mine if you
Don't think that was a big mistake. Let's try it.
want. No, we can always.
I mean, we don't have to be on mine. It's just.
I can also just pull the website up.
Let's log in on you and just pull it down fresh. Yeah, sorry.
I don't know where my phone is. This is my.
I think if we just stay on you and just make sure it's fresh, which maybe it was. Honestly.
No, mine was.
Too many. 546. That's all right. Not that big of a fire yet. Can't scare me yet. I have shortcut. I'm a lazy person and I don't like to type out stuff. Okay.
You may have the right. I will pick 5 special people to do control enter.
Yeah, just
Next to a neighbor. I'll share the screen.
Jesus, this hub is the computer struggling or the hub struggling? Does this look up to date? Oh, there's your fireworks.
We have fun. I have it. Again, as we build tutorials, we all learn new skills, so I was excited about this one. Thank you, Joe. I feel like I should say that mic now. Okay. I'll start by saying we are doing a database preview. So this is kind of, keep in mind the big picture here. The big picture is I'm trying to give you tools that you want to use with your upcoming projects. We're not going to look line by line at the code right now to figure out exactly what's happening. There is a whole tutorial tomorrow dedicated towards learning more about the database. So again, keep in mind, I call this the database preview. I'm going to show you some things that are possible to do on it. And again, this is so that you can navigate back to it and use it once you're trying to query and find things for your project. So we're going to keep it at that level. So our learning objectives right now are to have a first taste of the database. Some of you have maybe worked with it, maybe you worked with it last year, some of you maybe have not. I want to give you some code snippets to help you prep your data, and then this can sort of just get the gears turning for some of the project pitches that have been going on and for any other ones, and how you might actually access data. So the basics, what you need to know about this database are how the data are contained. They're contained into 4 big tables. The points data, the layer data, the image data, and the site data. So the colored things are kind of like what we commonly refer to these things as. The black text there is what they are formally named in the database. And then there's an image to kind of go along with each one. So points, we're looking at things that have a single value at a single location. You'll find that in the points table. Layer data is going to be something that has a single location, but multiple values are assigned to it. So that's very common in the snow pits when we have profile type data, or we have things like the snow micropenetrometer, the SMP, that samples in the vertical direction. Image data are going to be where we find rasters, raster collection. And then say metadata or site data, this kind of really made the point data really grow. So we kind of added, I say we, it means people at this table who build the database, double micas. Yeah, so site data are going to be typically things that are like in the header zones of the snow pits right now. And a lot of that information is contained there. So the first thing we're going to do is set up our computing environment. And so I have a couple standard imports here, some mapping widgets that I've been working with, and the database, the imports that are required for the database. So right here on this cell, if you do Shift Enter, you will run that cell. I see the number 1 up there. It means it ran. So one thing I want to point out is this little line up here. Notice where I import the 4 primary database tables. Can anyone see in this list of imports what piece of code imported those 4 tables? Don't be shy. Yeah,
The SnowEx.data and then import this.
awesome. So Jack's looking at this line right here. This is where imported. You can, if you just want to work with one table, you can just import one table. If you want to work with two, I typically just import all four, so I have them at my fingertips. Next, this is going to be some standard code that you're going to want to load the database. It has like I guess basically a URL, and then you're grabbing an engine and a session, and we will use those pieces when we build our queries. So, and then I added a print statement that says, yay, it loaded. And this is where we will see if we shock the system or not. This database is obviously growing in popularity, so normally it doesn't see this much traffic. Okay, so I'm just kind of thinking ahead here on some things that you might want to do when you start working with this database. And for me, I would think something that might be important is finding data that overlap between all the different data sets. So we're going to run through A through D, a 4-part example, for example 1, where we find all of the pits that overlap with a airborne sensor of interest. So this line of code here, I am going to build a query that queries the image data. So that's all the rasters, because that's where my airborne data are going to be. And I am going to look at the observers, which is like the different instrument types. And I'm going to make a distinct list of them, and I'm going to execute the query, and I'm going to generate a list that says I have USGS, UAV SAR data, and ASO data. The USGS is referring to the DEM that's inside the database. The UAV SAR is the UAV SAR data we have in there, and the ASO is the LiDAR data. So in my next block here, I'm thinking if you're a little bit unsure of the flight date, but you know like exactly which sensor you want to work with, this is how you would run this. So based on this string up here that I see UAV SAR team JPL, I have set that as the sensor name, and I'm going to now query all the image data for all of the dates, and I'm going to set that equal to which sensor I want. I'm going to get a distinct list of it, and then I'm going to execute the query by doing the .all. So I have dates, they exist. I am doing a little bit of coding down there to kind of clean that up and print them out in a nice fashion. And then I'm going to find all the pits that were done on those dates, and then I'm going to convert that into a GeoPandas data frame and print that out. Okay, so I can see now that it's too low, sorry. I can see now that the UAV SAR flights overlapped with 142 different snow pits. That is covering all the sites that we have in the database right now. The UAV SAR flight dates are now, they happened on these 1, 2, 3, 4, 5, 6 days. And these are all the pits that overlap with those dates. So what if I want to select an exact flight match? You're saying, okay, I have the whole list now. I want to pick exactly February 12th. I'm going to grab my first date from that list. I'm going to query the geometry, the site ID, and the date, and I'm going to return a GeoPandas data frame. And I now have that down to 40 pits overlap with one single date, February 12th, 2020. Again, we don't have to understand all the lines of code. I'm showing you examples of how you would pull overlapping data. So now say maybe you wanted a little bit more than 40 pits, and you maybe know like the meteorological history, and say like, I could take pits that kind of happen like a day before or a day after, and maybe you want a range of dates around a flight. Maybe you want a full week. This bit of code will get you there. In this bit of code, I do like a 3-day period, a day before, the date, and a day after, using the date time, delta time argument. Yeah, so again, I'm always converting it, my result into a GeoPandas data frame, and I'm doing a print statement to look at which flights. So we had 40 flights that were on the 12th. Now I have 53 snow pits that overlap in a 3-day period on that date. So now if you have, we're gonna kind of reverse the query. If you have a known date that you want to sample on and you don't really know what data are available for that date, you can set the date in this top line here, and then I'm gonna do a print statement for all of point data, layer data, and raster data, image data, that happen on that date. This one's gonna take a little bit longer to execute. Yeah, this might be a big ask.
Folks are getting errors.
Okay.
I think some folks are getting errors after. It's okay.
Again, this is mostly happening just because we're all hitting this at once. Things do work. Just by a show of hands, show me who has like red on their screen and errors. Okay. Solid.
We can just get back to that,
Yeah, sometimes you can just try to reissue it again.
Yeah. We could do like, we could like clear the kernel, and in most of my examples, I always re-import everything so they can just kind of pick up right from there. Feel lucky that this one worked. Yeah. So maybe there's better advice on this, but if my screen were really red right now, I would go up to the kernel button up here and do like, or clear all the outputs. And then maybe just don't run that huge query again. Again, you can move through each cell with shift enter, we'll keep running each one. So if everyone's been able to clear it, if you've needed to, you can then scroll down. Well, you should run the first one that says like computing, like set up our computing environment. And then we can jump down to number 2, and I reload the database again anyways.
I think it might have went down.
Went down, okay.
It's gone from, yeah, of course, the errors are coming earlier.
It's getting fixed in real time. This is what we call prime time.
I think I'll keep moving through it if you guys are good to follow. And yeah, that we'll do that. Because again, this is a toolbox for you to have. So we're gonna move on to the second example. You know how to find some overlapping data. Now I want to make a plot, and I'm interested in grabbing all the snow pit temperature profiles. And I randomly decided that I want to find all of the open canopy sites and look at those. So you don't necessarily have to rerun. I just kind of set this up so that you can see it from start to finish again. We're importing and we're loading the database. Here I'm setting up a query where I'm looking for all of the data. I set one that said not equal to Grand Mesa, so I kind of just focused on the time series. And then I grabbed all the sites that were classified as no trees. And I can see that I have a list down here of time series sites. So these are all the sites across that we have that were not contained at Grand Mesa and are open canopies. So you might wonder, how did I know what strings to use? This like no trees, just this like magic word I came up with. I want to give you a tool for that. You can begin, again, Michael will go over this, but you can begin by looking at the documentation on the data, on the docs page, on the database structure. You can scroll down to the sites table. That's what I have an image of right here. And you can see a list of all of the columns that are available within a table. So we have the 4 main tables, and then they all have columns. And so I can see here in the site table, it contains all this information. So these first bits here, air temp, aspect, date, easting, elevation, those are all things that I can query on. So I went down to a tree canopy and I did site name in this block. Oh, and that's where I run into my first error. Okay. Basically, this would print out a list that shows what the regional locations are, so that you can like copy and paste those strings and put those into your queries. And then it would show the list of different canopy types we have. No trees, open, sparse, dense. And you can grab it exactly like that text is and put that into your query. I might switch over to the rendered version. Okay. Yeah.
Should be good.
Cool, great. So, oh, no. Ah, wow. Kudos, wow. Magic, Bibble. Okay, so hopefully that makes sense. I'm trying to show you how I know these magical strings to use. And so I'm listing out our regional sites and then listing out, for example, what the tree canopy options are. And I went with this one that was no trees. Okay, here's a really big code block. This is gonna go through a nested for loop to plot all of the whole time series at one site and the temperature profile. And we'll see what it does. Yeah, basically I tried to set this up so that it can scale to different subplots, so that you can use this for other queries. It is set up with a color map right now. And in my first loop, I'm looping over every single site in that list. And in the second loop, I run through the list of dates that happened at that site. So you're at one site, you've gone there all winter long, you want to loop through those dates, and then I'm pulling out the temperature profile information. There's a couple things we have to do here where we want to sort the values so that they plot by depth, top to bottom. And then because we're grabbing layer data, we need to put those as float, because not all layer data are always float. So since we're working with temperature values, we can pass those as floats. I think it's still thinking, but it's gonna make a pretty nice plot where it plots about 25 or so that were in our list, and we can see the temperature over time of the snowpack by date. That's a good one. Has anyone's plot appeared yet? Or still thinking? Okay. Oh yeah, got one. Oh, you have a question? What did I change?
That's why I was so impressed. Doing it. Yeah, you're right. It's great.
Get any thoughts? Oh, I don't know which error, but I just helped her rerun and she was good. Sounds good. That's fine. Okay, cool. Okay, well, you. Okay, we won't quite see the plot right now. But I'm gonna continue through this so that we can stay on time. It's rendered on the website. We can view them and you can use the code. The last piece of this happens to be my favorite part. But we're going to sort of geographically combine like an interactive map and the database and plot things together so you can kind of see where you're grabbing data from. So I'm going to use a Python package, ipyleaflet, and I'm going to create a bounding box. Oh wait, maybe I can stop the kernel there. So that stop. Okay. I will jump over to the rendered ones. Not an error, just I couldn't make a pause. Yeah, I could have made it a much smaller query. Once it felt so powerful, I couldn't help it go up. I'm sorry. Okay. All right, and counting. So I jumped over on the website portion just to the rendered versions of these. And I'm now made it to the third one. Okay, so those of you that like to think about temperatures and snow and what those profiles are doing, I think this is really powerful. This shows, there's not a lot of context on, like where the sites are, what the conditions are, etc. But you're seeing through time, the darkest colors being early season, and through time, the yellow ones, we're getting a warmer and warmer snow as we transition into the melt period. And I think that's exciting to see. So back to this map that we're making. I set some bounds, and I'm kind of show you that you can use this map feature. You can build a rectangle over top. We're kind of looking at this area. And now I'm going to query the database. And I was interested in finding out where we had liquid water content measurements. So I set a query to filter on our liquid water content measurements. And I have a line of code here that puts that into the GeoPandas and sets the geometry. And then I plot that down here with my map, and I create a geo layer, and we run it, and we can see, and the nice part is here we can zoom in. That's like the hardest part with the time series, is because sites are so close together, like a couple meters apart, they often plot on top of each other when you're at big distances. So yeah, I like this. You can zoom in and see where we have these clusterings of maps. If you zoom in over Grand Mesa, you will most definitely see, I could put a square there. You'll see the pattern, the sampling design pattern. So that's where we have liquid water content measurements. Cool. So to recap that, the database has a lot of power. A lot of us are really new to using it. So that's why we're here this week, is to work on this. No one needs to be an expert at it. If you ask me off the cuff, I'm probably not gonna know how to build a query myself, but like I've been learning it as well. So the learning process, but again, that's really the whole point of these is we are building these tools together and using them. So some people have the knowledge of coding, some people have the knowledge of being on the ground, taking the measurements, but like, that's why we're a community and we can like have checks and balances on all of that. So yeah. So this is gonna jump into your time just a tiny second. Hope people's tummies aren't crumbling. I said quiz time, but really I just mean group activity. We can pause on this, but you're gonna jump to one more Google slide here. And the goal is you have free reign as a full group, individual, whatever, but we're trying to sort all these pieces into their proper data table. And there's totally some tricky ones there and some ones that you can argue both ways, but the goal is to help you know where to find these things. It's not meant to just trick you. But yeah, feel free, you have power to move them. And then maybe at the end, we'll find a moment and I'll make sure that they all get in the right spot. So thanks, everyone.
All right, thank you, Megan. And I think we'll check in on that activity in the afternoon. We're just going to finish our last session of the morning. I'm sorry, we're going a little bit into lunch. I know we're all getting hungry, but we wanted to get this session completed so you could think about it a little bit over lunch as we think about moving into the formation of our projects this afternoon. So Charlie and I are going to present a little bit back now on the opening slide deck from this morning. Maybe if I ask one of my helpers to repost that in the general channel so you can follow along. I know the screen is a little dark. But I wanted to start by, this is some of the content that's in the video that I shared when I introduced projects to you on Slack a few weeks ago. We start by telling you a little story of this database you just learned about. In 2017, HP was in a group project at the GeoHack. At the time we were doing broad sessions on anything geospatial. And HP can tell you more of the story, but I saw them just doing some work on learning about databases in general and how it might apply to the SnowEx mission. They didn't write a lot of code. They didn't spend a lot of time on GitHub. They did some research. They talked about things. They laid a bit of a framework for what might come next. Here we are in 2022, and we're teaching you about this database that's been built by amazing developers, and hopefully we continue to build that. That's the view that I take. This long view of how we can get a kernel of an idea started here, get the right people involved, and it continues to build over time in this open source kind of fashion. So let me just give you the 101 quick overview of projects, and then we'll do a little bit of pitching and then head to lunch. So really, in terms of topics to work on in a Hack Week project, the overall purpose, it's gaining experience, this immersive piece that I talked about at the beginning, really learning about what it means to work in teams, deepening your learning on a specific topic, meeting some new people in the process, building software together, and hopefully having a lot of fun. That's sort of, in my view, some of the funnest parts of these events. Over time, we started to get a little bit more clear on the different roles. And this is part of that scaffolding that I talked about, a little bit of lightweight, kind of like who's doing what in the project team that can help us to really spin up quickly, because we only have a few days to get things done. And it's not a sense of urgency, but it's like the more that we can clarify who's doing what, then the more efficient we can be and the more likely that we're going to get to everyone getting what they want out of the project time. So we define a project lead. That's usually the person who has pitched the idea. Somebody probably has access to data sets that you might be working with. And that person's role is to get to know everyone on the team, help people connect to the data, get just a sense of what the overall idea is all about. We're defining a role. We're shaping this role a little more clearly this year, and we really welcome your feedback in developing this out. And we're building, and Eli's going to share more on this, and Charlie as well, about how we can shape this facilitator roles. That is, the role of this person is to really help people get clear on the scoping and the shaping of the work, coordinate with the project leader, and bring a little bit of structure to what is a really messy process at the beginning of all this. And again, making sure that each individual gets to contribute and take away what they came here for. We also define a data science helper. Actually, that's somebody maybe from the e-science group or anyone in the team who has a little more expertise on, say, GitHub or some of the more technical questions. Again, this person's role is to get to know everyone, get to understand where each person is at in their work with data science tools, and then provide some guidance in answering questions. All right, hopefully you can see this, but this is the overall timeline of what we're proposing here. We already started at agreeing on Slack by this pitching, on the project pitching channel, getting your ideas out there, getting this ideation started. And that's going to extend into the yellow, which is day one. We're doing more of that after lunch, and where we can start to actually form people into teams. The actual work occurs, throughout the end of today and then into days 2 through 4. Often a mad scramble in the morning of day 5 to get a little bit of a presentation together, and really fun sort of sharing back out to everybody what we did during the week. And as I said, that blue zone there afterwards, that's the one that I am really intrigued by. Like, how do we take this work and build it over the long term? Any of you do work with ISAT 2 Day, you may know about the IcePix library, the shared community library. That again came out of one of these projects. Pitching, we're going to be doing that right after I finish up here. So we invite everyone to pitch an idea. It's already been great pitches on Slack. Not all pitches will evolve into a project that goes forward, and this is fine. It's just part of that process. We're here to help guide you in scoping that and getting people to understand a little bit more about your idea, and maybe get connected to forming a team with you. We'd like to have teams around 5 to 7, 8, up to 10 maximum, but if you get too large, it's a little bit hard to manage, getting the team dynamics to work out well. It's too small, you're not going to get that experience of what it is to work in a team. So go ahead and continue pitching on that channel if you still have some ideas that you'd like to share. We'll talk a lot more about the scope as we go along, but I said this earlier, the one thing that you can do is simply use the time, dive more deeply into the content that we're sharing in the tutorials. So you just learned a bit about the database. Maybe you want to spend most of the week getting really proficient with that. Again, it's a great use of your time. Everything from exploring data sets, working with a specific data science tool like machine learning, for example, would be a great use of time. Or maybe you want to just get a little more experience in the practice of open science and what it means to push some code in GitHub and have someone else work on it. And getting that process down is another great use of time. The last thing I'm going to say before I hand it over to Charlie is, we're aware that we're inviting you to pitch your boldest ideas here. And at the same time, we're in this really competitive academic environment. Let's be mindful of that. And if we are pitching something that maybe is an idea that we hope to a paper, it's really important to have conversations about that with your team early. Maybe think about what would it look like if this did evolve into something? How would we get the proper attribution to folks accordingly? So I think we're on to the slide. There we go.
I just wanted to say a little bit about when you're thinking about pitching your projects. Scoping of the project is important, and it's a bit of an art form. Unless you have led projects for half weeks before and have a little bit of experience, you may not have quite a feeling for how to define a project in which you can get it done in a week. And part of it is you won't know until you start meeting with your team, find out what skills they have and what tasks are going to be involved. So just giving you a little bit of heads up as some of you, I think, are still planning on pitching ideas that haven't been discussed in Slack yet, is thinking about, we got feedback from some of the prior project leaders. One of the things that came up was You know, if you have a well-defined project where the tasks are easy to define, you know we can get it done in a week, then it's a lot easier to manage for yourself. It's a lot easier for people to know what tasks are going to be involved, what we're going to work on, just distribute the work, right? But on the other hand, a lot of your coding wouldn't work, your personal research and work, and so you're going to want to do, maybe on a project involving that, right? Not quite sure we can get it done in a week. It may continue it on life on, and you're hoping that people will continue to work on it after the half week, right? But just a little heads up, if you go for that, and we're not saying you shouldn't, but just know that people have reported when they go that route, that they are spending the majority of their time managing, explaining things to the other team members and managing that versus doing hacking yourself. So there's no right answer. Just know, you know, there's a lot of things to balance when you're determining scoping. So think about those things, thinking about the project, and also when you're thinking about projects you're going to work on. I think we are ready to start moving into. Well, we want to give people. There's some, I think you've identified some people, and maybe even yourself, that still need to add their projects to the document. So in the project 15 Slack panel, Anthony has pinned to the top the document. If they, we're going to give you like 5 minutes. If you have a project idea and you have not put it in the document yet, we're going to give you 5 minutes to do that. After that, we're going to do a project pitching where you'll have 2 minutes to pitch your idea in front of everyone here, so that before lunch, everyone will get a chance to listen to all the projects, what's kind of involved, and then you get to go, hey, I want to work on that. There's actually 3 I want to work on that are going to decide. You have lunch to decide that.
So we'll ask even the folks who've already pitched on the project pitching channel to come up here in person as well. So you may want to just start organizing your thoughts. It'll be a 2-minute pitch. I'll make sure that you have that link here one more time. Thanks.
They can just pass this
Yeah.
between them, right?
That one's not working now.
Oh, it's not, okay.
Why?
And then Joe, after they have time to do that, you and Joe will do a demo.
Yeah, that's the next thing,
Yeah.
right? Yeah, totally. So I'm going to add a few more rows to that table at the top of the document because I see we're running out. My thinking on this is to put the basic idea in that first table. And then you scroll down the document, you have the more detailed content. Take 2 more minutes, the chance to pitch in the document, and then we can do our 2-minute pitches and then go to lunch. I have 7 projects currently listed in the table.
Pretty well.
Hey, can I have your attention down, please? Okay, we've got 1 more. Okay, you begin. Okay. I'm gonna invite Joe back up to the stage. And we're gonna do a sample pitch. Getting these pitches done quickly is crucial for us to get to lunch. All right, so the pitch is our chance to, we're on an elevator, Joe's gonna tell me enough information so that I want to get on his project by the end of the elevator ride. Although 2 minutes is a long elevator ride. The idea is, what do you want to explore? What's the problem really succinctly? Maybe what would you like to learn over the course of the week? What tools or data sets maybe have been used. People have been doing this in a certain way. It'd be so great if we did it with this set of tools. It's fun. It doesn't have to be right away, but giving yourself a hashtag. Hot Pal is one of them from last year. That's the only one I can remember. It's some way of identifying in a fun way your topic, and we'll use that as your Slack channel handle. Did you prepare your hashtag? Okay. I'm gonna set the time.
Okay, just a heads up, this is not the project list, this is a be ready for project, so I'm jumping. All right, so basically my idea is, I'm the DM different in person. I love lighter data sets, I love this and all the Snowflake data we have. So my idea, and I also say I'm an immediate Python person. My idea would be, I want to learn how to access the SnowEx database. I want to compare the lighter flights, how they figure out with the Snowflake measurements. So basically the learning skills I want to do is getting familiar with the SnowEx database. I also want to get myself better in the Python skills and how to visualize those things. Like I know first was data exploration. And I want to do it in a collaborative environment, so I want to also learn a little more how to use the GitHub thing to share my project and with other team members. So basically, this opened up the level for everyone, like we always want to do. Get familiar with technology, explore database, get more familiar with SQL, especially lighter data sets, daemon, inferencing. Also, kind of get into the error analysis. Maybe to say, look, do we have enough data for the snow pit? We can say it was a steep slope, north facing slope, kind of aspect information you have as well, and how does the lighter net come together? So hashtag would be lighter tell. So and that's all. Less than a minute.
Okay, so like invite all project leads, just come on up here, come up to the front of the room. It's a little bit easier than walking around having like whatever order makes sense. We'll go through our pitches. Should take us under 15 minutes, I hope, and then we'll head off to lunch. So yeah.
Okay, hi everyone, my name is Melissa Redden. So I work at NASA Goddard in the University of Maryland, and I am really coming at this from the snow modeling side. So if you run any sort of snow model, you get all this gridded output and you need to evaluate it somehow. I think anyone who's done this knows it can be a real pain to find the data, download the data, process it yourself. So wouldn't it be great if we could have a tool that's already out there that can help us with our model evaluation? So my idea is I have some sample snow model output that we can start with and build a notebook and just pull in the data, the SQL database, pull in other various whatever observations that we think would be important to have in order to do this model evaluation. And ultimately, I think that this is a tool that if we can kind of extend this into the fall, develop this notebook and share it with some of my colleagues at NASA Goddard, because this is a tool that we need to have. Oh, I'm not creative. We'll come up with a hashtag together if it's fun and activity. So that's mine. Thanks.
Everyone, I'll go quick. My project is at the top of the list on the document. It's the SWORD satellite transceiver idea. I don't think I'm going to keep going with that. If anyone else thinks it's interesting enough to pick up on, these are basically small widgets that will let you send kilobytes of data per day. I think total like a few hundred kilobytes per month, up or down via satellite network. So I didn't realize that SnowTel sites already talk to Iridium satellites or something. But anyway, if anyone else has other ground sensors that would work for this, I'm happy to lend them. Showed up on bringing them up so far, but yeah, I'll likely jump to another project.
I just added mine. It's forming in real time. But I do a lot of what Melissa was just talking about, and I model a lot of stuff, and we use station data to try to figure out if that model data is any good. And the question that almost always comes up at the table is, okay, well, if this station's low and this station's high, what do those mean to the model domain? You know, do we change this one so that it goes up or down? So what I'd like to do is look at stations near SnowEx data and look at how station data is correlated to SnowEx data, and hopefully draw some insights on how important stations are to the surrounding area. I think I want to call this hashtag spatial station, something like that. Space station. That's what we're gonna go with, space station. Thank you.
Sorry for stealing your thunder there, Mike. Perfect. Great. So I'm Tate. This GPR and LiDAR fusion is kind of an idea that I've been working on since last summer. And I'm a mat ladder, so I've done some of this work, and it is involving multiple data sets and integrating them, and that's challenging. Whether you're in different projections or different accuracies and things like this. So I feel like there's a good bit of synergy with Joe's idea, getting grasp on this LiDAR data and using it in the database. And it seems like a lot of people are piling on. So there's going to be, I don't know, definitely a good emphasis on having to wrangle the LiDAR data, having to parse it out and find the pixels that you need to do all this comparison and evaluation. That's a pretty big computational step. So I'm curious to learn more about how Python tools can handle these big data sets and be able to search through them. And that's going to be key to integrating data sets and bringing in other information like vegetation types and canopy density and things like this into this project as well. So people with skills and interests in that type of work, let's do it. Hashtag, I had a great one for space station, but I really don't have a hashtag right now, so we'll work on that.
Hello, my name is Jonas. I'm very new to all this. I thought more people would be pitching. But what I want to do is actually look at a very specific model, the DMRT model. That's a radiative transfer model. I don't know if some of you are familiar with that. And this model needs some input parameters. And I was actually hoping to find a link between these input parameters and SnowEx snow pits that are available. And if we could find this link, it would be great to then make some kind of notebook that can, where we can look at these, where we can do it in a way that we can do it not have to do it manually anymore, but then do it automatically, so that we can share this with the community. It's basically the same idea as the model evaluation thing, but then specifically applied on one model. And if there's interest, you can for sure contact me. I'm also new to the DMRT, so if someone has more expertise on that, feel free to contact me. I would love to talk to you. Thanks.
Hi, my name is Anna. I'm here at Github, and I work a lot with ISAT2 data. And I went to Western Snow Conference months ago, and met Zach Keskinen, who has a lot of experience using UAV SAR data. And so our idea is to try and combine ISAT2, which gives you elevation data, which can then be used to get snow depth, to use that data to help constrain the phase shift of the SAR in SAR data. And then hopefully that once you establish that initial depth, then subsequent INSAR data can be used to update your snow depth information throughout the snow on season. So yeah, I guess there's multiple goals with this project. I mean, we're just trying to combine the instruments that we both work on. I think people from a lot of different backgrounds who work on this project will be trying to use the SnowEx database to get data for ground observations to help validate what we're doing. People who are interested in ISAT2 and also who are interested in INSAR data be interested. So yeah, we're looking for people to join, and we'd love to have you. Yeah, thanks.
Hello everyone, I'm Jiyoung Kim from Yonsei University in South Korea. So I propose the snowman climbing, estimation, so snow timing is critical for like hydrology, vegetation growth, and carbon cycle, climate change, for everything. So I was thinking that so we have the SnowEx data, and then we could estimate the uncertainty in the remote sensing based snow timing, and then from the various remote sensing data like MODIS and then also the SAR data. And once we have that uncertainty, we could also estimate the long-term trend of the snow timing. So how those snow timings could be changing over the time, and then what kind of factors like topography or elevation or slope or like the temperature, the micro climate variation over the site could affect the snow time and long-term trend. So we could analyze that kind of fact. So that's what I was thinking so far. So of course, I'm open to anyone with any background. And for the name, snow free, I guess, because snow is melted. So, okay, thank you.
Yeah, I'm Boger Young with the NRTS Snow Survey. People know that as SnowTel. We actually have a unique opportunity right now. We're going to be putting together a RESTful API that should be replacing our current web service. I don't know if any of you have ever used our web service before. The web service is very hard to deal with, very not modern. I don't really see this as a full-blown project, but if we could maybe make like a breakout session for people that are interested in getting input into how we actually construct the JSON returns from this API, I think it can be super helpful to take lessons learned from anyone who's ever tried to use our API. And what we're really trying to do is consolidate the methods to just a couple methods that can return everything you need based on flags. Obviously, having a REST API will allow people to access our data a lot quicker. It's not just SnowTel data. We actually warehouse data from USGS, Bureau of Reclamation, tons of different data sources. So yeah, anyone that's interested in kind of like literally giving input to how this thing's going to be constructed, this is a great time to do it, and here hopefully to do so. So if you want to just sign up for this one, and maybe like we'll do a breakout session, I'll talk to the admin people and see if that's all kosher, but sure it would be. I figure a couple hours we could probably get a lot of the ideas on the table, and I call it the API for yet another API.
Everyone with great pictures. And what were we? Oh, Charlie, we were gonna check in on facilitator. Yes, thank you.
We're making this up as we go. No, I'm just kidding. Okay, so Anthony earlier today mentioned the role of the project facilitator helper. That's someone that's just, I'm looking mainly towards the organization team. If you know that you're not going to be working on one of those projects, we could really use your help to help some of the project leaders. When we come back from lunch, we'll have like an hour activity where we are mainly starting to just sketch out the basics of the project. And it's going to be a lot of sticky note, like everybody writing ideas for tasks for that on sticky notes, just so we want a little help, a little support for the project leaders, especially those that are new to this. So if you're willing to volunteer for that role, and we'll teach you about it along with everybody else, just maybe let me know in the education team Slack channel. I'm looking for 3 to 4 additional volunteers for that. And then we should be back and sign up for a project and be back in an hour.
An hour, so that takes us to 1:20. Eli has another quick thing to say.
Yeah, I just wanted to follow up on what Carly just said, that this is really mainly for today. Is the big thing, like something like this, like something for this activity that supposed to be teaching is be
So that facilitator role is really crucial for this opening scoping session that occurs this afternoon. If you didn't hear any ideas that really resonated with you, it's not too late. Come back after lunch, chat with us. We'll form a project based on what you'd like to work on. So let's think about it over lunch. Come back at 1:20. Your cards, if you don't have one, will be right at the front desk where Jenny is. And she'll also tell you where we're going, which is just over here, I believe. It's called local. It's a cafeteria. Questions? Yeah. Do we leave laptops? Christie? No. Thank you for asking, and we didn't think about that yet. It's not gonna be locked. The question is whether one of our team is gonna be here.
They're working outside or being in here, there'll always be someone in the room, right?
I can really be sure that one of us administratively is here, including myself. So, sorry, this is all part of like, we're back in person and we have to think about all these things again. Why don't you bring your stuff with you? Apologize